Hello everyone, for First Updates now, I'm Tyler Olds, and you're watching Behind the Bot. It's a fun show where we dive deeper into FTC robots and what makes them work. And today I'm here with team number 12043 Power Surge out of Dyer, Indiana. 12043 had an opportunity to play both in hybrid and in in-person matches, and recently just won the Indiana State Championship and is Alliance captain. They also won the Motivate Award at the state championship and Second Inspire at their league championship. Joining me today from Power Surge is going to be Braden, DJ, David, and Daniel. And of course, we're going through this robot, including the ring journey as it goes through, talking about some strategy for states as well, too, which I'm excited to hear about. The odometry and the robot, all this and more coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So, Braden, we're going to be starting out with the intake on this robot. So tell me more about what your intake is, some of your strategy behind it, and maybe some of the iterations you went through designing this award-winning intake.
Well, to start out, the intake was definitely a difficult piece to make. We started out by using mini mecanum wheels on it because that was definitely not our first iteration of it. We came to this after we used these and a bunch of these on our first one with it being long to make it go in. These mini mecanum wheels would hook on the ring and pull them into the robot. We also needed to make sure that it intook from the front so we could shoot from the front. After that, we had to make it so that it went into the robot as fast as possible. And that is where this comes into play and where all these bars come into play. After that, then it goes into this bucket system right here, where it then go into the shooter.
So a couple of questions to follow up with on that is, first off, starting out, what material are those, like those little whisk things that you have on your hopper type area? Like, and what is that and how'd you come up with using that?
Well, we have zip ties tied to an axle, and then on that we have surgical tubing. And we use surgical tubing because it gave some grip to the ring. And then we put it on some zip tie to make it so it's not as flexible.
Sure. And then on the intake itself, is that the drop down intake, does it drop down and stay down the entire match, or are you actually able to manipulate that up and down?
It does start up, but once autonomous is over, we drop it down and keep it down.
Well, very, very effective and smooth on that, no doubt. And we're going to be kind of continuing going into that shooter transfer system in just a moment. But I just want to comment. I love the design and the uniqueness that came with that. We've seen a couple of robots use similar type hopper things on that, but what you described to me might be a first I've heard from that. So let's keep moving on, if you don't mind. We're going to go into DJ, who's going to be talking about the shooter transfer system into the shooter itself. We just saw what looked like maybe an elevator or something like that, pulling it up. So DJ, tell me a bit more about what's going on.
Yeah, so the problem we started out with is that the rings are coming in and they're angled facing the front of the robot and down. And we need to shoot them facing the front of the robot and up. And so what we did is we put this on a linkage where it actually rotates freely up to mechanical stops. And what that does, it allows it to rotate to the correct angle first and then pulls it up like that. There are a number of different things we use to enhance this control, and we actually use color sensors here to make sure that I can't pull it up too soon, because if this is blocked, it can jam underneath the shooter if there's a ring sitting right like this. And so while those color sensors are sensing that there's a ring there, it won't allow me to pull it up. And we tried to use encoders to control this, but the encoders tended to drift. And so we ended up using limit switches on either end. We apply a slight pressure down at the bottom. You can see we got a limit switch right in here, and we got a limit switch down at the bottom here. That just allowed us to put a slight pressure down on that limit switch. When it goes up, it gives the power to come up and puts a slight pressure up. That eliminates any bouncing that we had with encoders as well. And it's just overall been a great system. Now, going into the shooter, that ended up being about 4,500 RPMs for us. So I also, later on in the season, added these steel discs to the robot. That was just so that the wheel could spin longer. It takes almost a minute to spool down now at this point. We also encountered a problem in the season where we had rings that were very squishy and some that were not very squishy at all. And so we actually added this just to see what it would do. It's a 1/4 inch thick piece of aluminum just bolted inside of the shooter and squished the rings that much more. And that solved all our problems. Both types of rings shot equally well.
So let's go back to your the transfer mechanism for a second. I want to talk more about that color sensor that you have on it. So the color sensor is essentially detecting the color difference between the ring and what your hopper is, right? I'm assuming.
Basically, what's happening is this one does not have a light on it,
Sure.
so it is only the only time it actually sees light of any significant value is when it sees the light coming from this sensor over here, which is actually just being used for the light.
Yeah.
And so when there's a ring right here, it blocks nearly the entirety of the light. And when it falls down just a little bit more, it is completely free, and that is what allows the difference in color to be observed.
Sure, that makes sense. So what do you do if it does get stuck, though? Like, if you got a ring that is stuck in there, like, do you just try to jostle the robot or slam against the wall, or what process do you do to try to get that unjammed?
Actually, these parts of the intake are specifically spaced so that it does not jam at all. They went through 6 different types of these ramps, just modifying this distance slightly so that it always pushes fully in as long as we haven't broken a bunch of these.
So one of the other things I wanted to ask you is on that flywheel in particular. So you have you added a flywheel on there, and you mentioned it takes about a minute for it to spin down, which is good, but that also typically means it takes more speed for it to speed up. And of course, one of the other advantages with that, though, too, I shouldn't say a minute, it takes a little bit more time for it to speed up. And then an advantage, though, is that it's less time between shots. So how do you calculate, when you're at the right velocity and maintaining that velocity, and how long does it take between shots for you as well?
Yeah, so at the beginning of the season, that was a bit of a problem, and that's why the weight was added so that they could shoot immediately right in between shots, so that it's not slowing down. So we're shooting them off about once every half a second or so, and this actually having this extra weight on there here did cause a problem for us, though. The built-in control on the software did not know how to handle this much extra weight on here, so we were ending up with a bit of a sine curve for the power of the motor when trying to set it to a velocity. So what we ended up having to do is utilize a PID loop control to get this to spin at a consistent speed throughout the match. It takes about 5 seconds or so to spool up, and then we leave it on throughout the entirety of the match.
Well, that seemed to be a quick speed up to me. That looked really good. You mentioned about a half second between shots. That's what it looked like to me as well, too. So thanks for taking the time to tell us more about that. Dave, we're going to continue with you talking about the chassis on the bot, and then a little bit of code as well, too. I know you guys got some odometry wheels and some other things you wanted to mention as well.
Yes, absolutely. So one of the important parts of the core design for the robot is the chassis of the robot. So we started using this design last year and evolved that into the design that we have this year. So we have a solid piece of aluminum for our chassis. This makes it a great system for mounting everything on the robot onto. This also allows us to get very close to the ground, so we have a super low center of gravity, allowing us to have really good maneuverability and balance, as well as ensuring that we never get on top of any rings or having to deal with anything getting in the way of our wheels or odometry pads. So we have the Mecanum wheels mounted right to the chassis down here, and then the odometry pads are right here. So the odometry pads are really important in both teleop and autonomous. So for autonomous, we're obviously using them for figuring out exactly where our robot is and then calculating where we need to go to on the field relative to our current actual position. But we also are able to use them in teleop because using the press of a single button, we're able to return back to the position that we last shot from, allowing us to eliminate a lot of driver error and save a lot of time in between shots.
How do you compensate for drift though? Because when you're in teleop though, using odometry is great, but you do get some drift over time. So how are you compensating for that when taking shots?
So we are resetting our position that we're shooting from every time we shoot. So every time the driver shoots the ring, that position is saved, and the secondary driver is making little tiny adjustments in between shots for exactly where we're going to be shooting. So we're only ever off by as much drift as we could get in the span of collecting one set of rings, which usually is not very much.
Yeah, that makes sense on there. Interesting on that secondary driver making those minute adjustments too. So we're going to be wrapping up on here. I want to talk a little bit more about the state championship, and we're going to be going over to Daniel for that. And Daniel, something I got to ask you going into the Indiana State Championship, a team that I think a lot of eyes were on was 12835 Pixelated, which is a team that we've had here on Fun before, and they're a fantastic team. You actually ended up winning the state championship with them. And you guys were the alliance captain. I know going in though, there was a lot of concern, in regards to how do I take on Pixelated and how do you, beat them in a match should you go up against them, which you did. And I know you went to defense a lot. So tell me about the thought process behind this. Why focus on defense and how did you go about doing that? And how did that play into your strategy for the state championship?
Yeah, so going into the state championship, we saw by OPR, we were probably about fourth or fifth going in. And then we noticed when we were against them in a qualification match, we decided to play defense against them because we thought at that point our only hope was to get picked by them, and we wanted to look as a threat to them. So when we ended up playing really good defense against them, holding them down to 102 points, and I think 4 in the high goal, they dropped down a bit in the rankings, and we were up to number 3. The number 1 team no longer wanted to pick them, so then they picked number 2, which made us the second captain, and then we were able to pick them and then win with them, because we were the only team that was able to play defense against them.
So that's the interesting thing to ask you though on that is, when you're talking to your other alliance partner in that match, I mean, how did that conversation go down? Were you just like, hey guys, you know what? We're just going to play defense. You guys do your own thing. Or was there some other deeper conversation that went into prepping for that match against Pixelated?
When we talked to them, they were not a very strong robot for shooting in the opposite side, which was, in our minds, the better strategy. And our robot actually has a power setting on the shooter specifically for shooting in the mid goal, and we had practiced playing against them. And so we decided that it would be best if they shot in the high goal while we shot in the mid goal and defended against Pixelated.
Sure, that makes a lot of sense on that. Danny, anything else from a strategy standpoint, maybe throughout the season that encompasses what Power Surge's strategy is going into the season or moving forward or anything like that you want to discuss?
Well, one of the big things was we thought about the fact that Indiana was having the leagues in remote and the state competition in person. So we built our robot specifically for in-person competition. we built a bigger robot than most of the teams, which meant that we were not getting shoved as much around on defense, which did really help in the end.
No, that makes a lot of sense, and good prep with that as well, too. And I think I'd go the same route that you guys did for that. I would always assume that in person at some point would come back, and glad you got to compete in person. And congratulations again on your state championship victory for that. Once again, checking in with team number 12043, Power Surge, coming out of Indiana. Congratulations on your state champs, and thanks for taking the time to speak with us about your robot and the incredible design that you have. Power Surge is done after this season, but what a great legacy you leave behind, and we wish you best of luck no matter what your next steps in life are. We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.